Okay, let's find the domain first. A domain is the valid x input into this function. And there's two restrictions. The first comes from ln. Okay, so any input into ln, in this case it's x minus 1, needs to be positive. Okay, so x minus 1 needs to be greater than 0, so we get x is greater than 1. Okay, but that's not all. We also cannot have this whole base, denominator, 1 over ln of x minus 1, this cannot equal to 0. Okay, so we have to investigate when could it possibly equal to 0 and when will that be. So let me bring the 1 over to the other side. We get ln of, well, essentially what it comes down to is that this cannot be 1. Right, it cannot be 1. If it does, because you get a 1 minus 1, you get a 0. So x minus 1 would equal to 1 if you get e to the power of 1. If x minus 1 was equal to e to the power of 1. So if x is equal to e plus 1, then this whole thing will turn into 0 and it'll become undefined. So there's two restrictions we have to combine. Okay, that x cannot be e plus 1 and x has to be greater than 1. So what that means is this: in the interval notation, it has to be greater than 1, but you have to exclude e plus 1. Okay, union, exclude e plus 1, and go all the way to infinity. So that's a domain. Now let's find the derivative. So let's differentiate the top, and we get 1 times by 1 minus ln of x minus 1. Subtract by, leave the x alone and differentiate the bottom, and we get a minus 1 over x minus 1. Okay, and then you got to square the bottom. Okay, so we get 1 minus ln of x minus 1, and you get a plus x over x minus 1. Okay, so there's nothing too much we can do to simplify this. We could multiply top and bottom by x minus 1, let's say. So we get a x minus 1 minus x minus 1 times by ln of x minus 1. And that will turn into just x. Okay, and then the bottom will have on x minus 1. Okay, so you can see that the 2x can combine to give you 2x. So that's as simple as it gets.